All right, so we're looking at antiderivatives, which is exactly what it sounds like, right? We've been doing derivatives pretty much all year. And an antiderivative is an inverse of a derivative. So what we have here is we're given a derivative. We're given f prime of x, and we're asked to find f of x from that. So anybody got an answer for me? What do you think? If f prime of x, let's just look at that first term, right? Because when you're doing derivatives, you can do one term at a time, right? You can treat separate terms completely separately. So if we just look at that first term, 2x cubed, anybody have the antiderivative of that one? Katie? 1/2 x to the fourth. And if you want to check that, let's take a look at what Katie did there. If we were doing the derivative of this, you'd bring the 4 down and multiply it by the 1/2, and you'd get 2. And then you'd subtract 1 from the power and get 3, right? Absolutely. So you can see that it works. Good. What about the 5x squared? Somebody else? Sydney? 5 over 3 plus 5 over 3 x to the third. Again, double check. If you bring the 3 down and multiply, it'll cancel the 3 on the bottom, right? They'll reduce to a 1, and we'll get 5. Subtract 1 from the power, we get 2. That works. Very good. What about the minus 2? Anybody got that one? Somebody else jump in. Yeah, good Lauren. Minus 2x, you got it. Very good. If you take the derivative of minus 2x, you get minus 2, right? So far, so good. Now, there is one thing missing here. Anybody know what it is? Lauren, go ahead. There could be a constant, right? What if it was like plus 7? When we take the derivative, we get 0, right? But is there a plus 7? Maybe. Maybe there's a plus 36.2 pi, though, right? We don't know. So does anybody know what we do here? Nate? We do plus c. You got it. Uppercase C is a customary thing to write there. It's called the constant of integration. We'll talk more about the word integration later. Doing an antiderivative is a form of integrating. But that constant of integration, when you do what's called an indefinite integral or an antiderivative, right, like we just did, then you need to account for the fact that there could be a constant added there. We don't know what it is. It could be anything, right? It could be 7. It could be 39.2 pi or whatever I said. It could be 0. Maybe there isn't one, right? It's just 0. If it's 0, that's fine, though. C can be 0. Make sense? But we do have to account for that possibility. So that's it. We did the antiderivatives of all of those. And we were on all of those, we were just using the power rule, right? But backwards. So can we write a general power rule for antiderivatives? Here, I'll write it in the same format here. F prime of x equals, and I need a power function. So I'm going to say a times x to the n. That's how we did it when we did the power rule for derivatives. And see if you can generalize that now. Like what all of our students who volunteered here did. Maybe you're just kind of thinking about it for those specific ones. But can we make this a general rule? Give everybody 10 seconds here and then. Lauren, what do you think? Let's take a look. So, first of all, I usually think about this part first. Lauren added 1 to the power. You guys agree with that? Does that make sense? If we're doing the power rule, when we do a derivative, we subtract 1 from the power. So when we're doing an antiderivative, we're going to have to add 1 to the power. Absolutely. Yep. And then the other thing she did is she divided by n plus 1 out front. And if you think about it, if we were doing a derivative from our answer here, right, then we would be taking this n plus 1 and multiplying it in front. and it'll cancel out perfectly, reduce perfectly with the n plus 1 that she's dividing by, right? So that is absolutely right. That's exactly what we want to do. There's just one thing missing. Kitty? Plus C. So this is our power rule for antiderivatives. All those derivative rules we learned, every single one of them, if you do it backwards, is an antiderivative rule that you already know, right? So there we go. That's the first one you got. But remember, the power rule isn't everything, right? There are other derivative rules. Now, I put some other examples on the board over there, and I'll put them up here in a minute and maybe do another video or two from these. But see if you can try those. Again, you're just thinking about the derivative rules you already know.